Okay, I'm going to do a little review on what we've been doing in geometry class. Just for about the last week and a half. So about last week, I gave the students an assignment, and they took their ruler and they drew in their notebooks um, 4 triangles, and we just did them one by one. So how I did it was first one, second one, third one, fourth one, and I had them draw first a triangle with these side legs. And I went around and I checked it, and some students had difficulty with it. And also, you might want to try this if you have not been in class. You might want to get a ruler and actually try this exercise. It would help out. And then we went to the second triangle, and they had these side lengths. They had to make a triangle with these side lengths. Then we went to the third one. So at this point, I would stop it and try to draw a triangle with these side lengths. All right? Try and draw a triangle with these side lengths. So start with this one, then go to the second one. All right? Okay, I'm back now. Hopefully you were able to do that. And I want you to try to draw a triangle with the draw a third triangle with these side lengths, 2, 3, and 6 centimeters. So try and do that and come back. All right, after trying that, you should have realized that that wasn't that easy. And matter of fact, you should have thought it was very difficult. And really, you should have come to the conclusion that maybe this is not even possible. And then I want you to try this fourth triangle. So try and draw a triangle with these side lengths and come back. Okay, you have a triangle with these side lengths. Hopefully you do not have a triangle with these side lengths because it is not even possible. You should have come to the conclusion that something is not going to allow you to do it. All right? And if you look at these triangles, this one, it might have taken some time. You should have been able to do it. This one, the second one, you should have been able to do it. It might have taken a little time. The third one, you should have come to the conclusion that something's not right. The fourth one should have been pretty obvious that I'm not going to be able to make this triangle. And there's a reason for that. I want you to look at the look at the 4 triangles. It's been a long day, so forgive me if I stutter a little bit here. Look at the 4 triangles, and you notice that the ones here that I underlined, you were able to make a triangle, and then the third and fourth one, you were not. So look at these side lengths and try and figure out why was it the case that I could make one for the first 2, but for the last 2, no. All right, so think about that for a second and come back. All right. If you notice, look at the 2 shorter sides on each of these, every single triangle. Just focus on the 2 shorter sides. If you notice on the first one, the 3 and the 4 add up to 7, which is greater than 5. And on this one, the 4 and the 6 add up to 10, which is greater than 8. Look at the third one, the 2 and the 3 add up to 5, which is not greater than 6. And then the 3 and the 4 add to 7, which is not greater than 9. So the reason is we have a theorem about triangles, about their side lengths. So let's go look at that theorem. All right, it's called the triangle inequality theorem. All right, so this would be a good thing to write down if you haven't been in class. The sum of the length of the 2 shorter sides of a triangle must be greater than the length of the third side. If this is not the case, you cannot form a triangle. So look at examples 1 and 2 and see if those 2 examples could form a triangle. You don't even have to draw it, and I'm going to add a number 3 here. Number 3, excuse me. Let me see, 6, 4, and 8. No, 6, 4, and 10. All right, try and do those three problems. Do the following, do these three sets of sides. Is it possible to form a triangle? So look at each one. Okay, if you look at number 1, look at our two shorter sides. Our two short sides are 4 and 5. If I add up 4 and 5, that is equal to 9. That is greater than my third side. Remember, that's what the theorem said. The sum, that means adding, of the length of the two shorter sides must be greater than. It doesn't say greater than or equal to also, so keep that in mind. Must be greater than the length of the third side. If this is not the case, you can't form a triangle. All right, so for this one, the sum of the two shorter sides is 9. It is greater than the third side, so that's yes, you can form a triangle. Now for the second one, 6 and 8 adds up to 14. That is greater than 13, so that's a yes. And number 3, 6 and 4 add up to 10, which is not greater than 10, so that is no. Those three sides cannot form a triangle. If you look at this example here, if you actually went through and tried to draw the triangles that I gave you before, the 4 triangles, this might have been what you had. You might have had your side down here and you were like thinking to yourself, well, these just can't meet, no matter how low. Usually what happens, as we do this more, the students, they try and make them lower and lower and lower and lower, and then they realize those sides are not going to meet no matter what I do. That's the reason why. This theorem tells you why you have to have a certain length of sides to form a triangle. Okay, so we've been doing that. That's one thing. All right, so I'm going to come back with something else. This is actually probably the more important part of it. All right, if you look at this problem or this situation that I gave to the students, the question is, you're given two sides of a triangle, so 9 and 5. Find the range of possible measures for the third side. So keep in mind that the third side could be the shortest side or it could be the longest side. But what's the range? So I want you to just think about this. Could it be 4? So could the length of the third side be 4? If that was the case, the two shorter sides would be 5 and 4, and that'd be 9. They'd have to be greater than the third side. Is that true? No. So 4 won't work. But what if it was 4.1? Would that work? Well, think about this. Your 5 and your 4.1 would still be the two shorter sides, but they would now add up to 9.1, which is greater than 9. So this would be a yes. So it looks like anything above 4 would be okay. So for this problem, I actually said we're going to let x equal the third side. So we wrote x is greater than 4. So x has to be more than 4. But we can't just say more than 4 because that would mean, well, then 100 would work. Well, if I put 100 here, obviously 100 is not going to work because 9 plus 5 is not greater than 100. So let's think about what would work. What about, so x is greater than 4. What about 10? Would 10 work? Well, the two shorter sides would be 9 and 5. And 9 plus 5 would be greater than 10, right? So that would work. 10 would work. But what about 11? Would 11 work? Well, 9 plus 5 would be greater than 11, so 11 would work. Well, what about 12? Would 12 work? 9 plus 5 is greater than 12, right? 14 is greater than 12, so 12 would work. Well, what about 13? Would 13 work as a third side? Well, 9 plus 5 is greater than 13. Well, what about 14? Now we get to a situation. 9 plus 5, 14 is not greater than 14. So the third side cannot be 14. So it can be greater than 4, but it also must be less than 14. So our ranges are from 4 to 14, not including 4 and 14. And we can do a number line, not a number line, but in any inequality we can write it out. We can write it like this. 4 is less than x. 4 is less than x. That's the same as this. It's just flipping it around. So These are equivalent, and then I just write 14, and this x is the length of third side. So the length of the third side, it could be anything from 4 to 14, not including 4 and 14. So if I were to say 4.1, and I put this in place of x, it would be true, right? 4 is less than, right? 4 is less than 4.1, and 4.1 is less than 14, all the way up to 13.99999, right? That would work also. But 14 will not, 4 will not, everything in between will work, okay? So that's something you're going to need to know how to do. All right, if you want. Okay, here are some problems you can try based off what we just did. So try these problems and come back and see if you got them right. Do these sides form a triangle? Is it possible? So try them and come back. All right, for this one, this number 1 is, remember, the two shortest sides have to add up to more than the third side, which in this case they do, because 5 is greater than 4. So this is a yes. They can form a triangle. On number 2, the answer is no, because 6 plus 20 do not add up to more than 28. Number 3 is no, because 7 and 15 do not add up to more than 22. And number 4 is yes, because 9 and 3 do add up to more than 11. All right, let's do, so look at these problems now and see if you can do them. Find the range of possible side lengths for the third side if you're given two sides already. All right, on number 1, the least that this side can be, remember the two shortest sides have to be longer than the third side, the sum, that is. So let's just say this were 8. Would that work? Well, 8 plus 5 is 13, which is not greater than 13. But if I had 8.1 or 8.01, or in other words, anything greater than 8, they would work, or it would work. So I'm going to say x is greater than 8, and I'm going to say let x equal third side. You could say s, actually. It doesn't matter what you use. I'm just using x right now. So 8 would not work, but anything greater than 8 would work. But you have to have a highest length also. So would 18 work? Well, no, 18 would not work because 13 plus 5 are not greater than 18. But anything less than 18, so 17 would work. 17.5 would work because 13 plus 5 is greater than 17.5. So anything below 18. So we can write x is greater than 8, x is less than 18, so I can write that as 8 and then 18, all right, where x is the side, third side length. All right, so that's for number 1. I'm not going to go over all these because it's going to take too much time. If you have a question about them, you can come and ask me, but that's how you do that, okay? All right, this is going towards what we've been doing this week and the end of last week. So this week would be the week of, Tuesday was our first day, which was the 13th. We started it the week before. We had a long 4-day weekend, so it was a long break. But I asked the students, is there any relationship between the exterior angle marked in red? This is exterior, that means it's on the outside of the triangle. It's not on the inside. It's formed by these two lines here. It's not an interior, it's an exterior angle. So what is the relationship between the exterior angle marked in red and the two non-adjacent angles marked in green? All right, non-adjacent means, well, let's look at it this way. Adjacent means next to, non-adjacent means not next to. So This one I'm marking in green that you see right here, hopefully if you're paying attention, that's the adjacent angle. The non-adjacent ones are these two, the ones that are not next to that exterior angle. So my question to the students was, how are they related to one another? Well, if you look at, and so think about that. I don't know what you've missed or what people have been, some students have not been here. Think about how do they relate to one another? All right, so try that. Think about, okay. All right, now, what would happen, would you know more if I told you that this angle on the outside was 122 degrees? Now, one thing hopefully that you do know, if you've been in class, is that a straight line is 180 degrees. So, this angle in red and this one that I'm about to do in blue add up to 180. So I would know that this angle on the inside of the triangle is 58 degrees. And so now what do I know about the green angles? If that is 58 degrees, what do I know about these two green angles? Green angles. Think about that. Hopefully you remember or have heard that the amount of angles, or there's a better way to say it, the interior angles of a triangle always add up to 180 degrees. So I don't know what A and B are, but I know that this angle at A, this angle at B, and this angle here at C that I'm pointing out, I know that they have to add up to 180. And if I already know that this is 58, then what do these two green ones have to add up to? Well, it's going to be 180 minus 58, which is equal to 122. So I know that these two angles have to add up to 122 degrees. I don't know how much each one of them are, but I do know that they add up to 122 degrees. So that tells me that they must add up to what? Well, they must add up to that exterior angle. And it doesn't matter what kind of triangle you're looking at, it's always going to be the case. So that leads us into our next theorem, which I had the students write down. All right, it is the exterior angle theorem of a triangle. And so take a second look at that. Okay, hopefully you had a chance to write that down. If you look at this diagram, it's saying D is equal to A, which we have here, plus B, which is what we just saw on this diagram, that this angle is equal to these two non-adjacent interior angles. So you're going to need to know that as we move forward. Okay, here's an example of when we're going to use this. All right, this angle on the outside, this is the exterior angle. All right, we just learned in our theorem that that is equal to the two non-adjacent interior angles. So if I was asked to solve for x, I could set up an equation. I'm going to have 2x plus 4, that represents the angle on the outside, is equal to, we just said, the sum of the two non-adjacent interior angles. So one of them is 60, we know, and then the other one's represented by x. So we have our formula, or our equation. So now I can go ahead and solve that. Now I'm going to have subtract 4, subtract 4. I'm going to have 2x equals 56 plus x. Now I'm going to subtract x, and I'm going to get x is equal to 56. So we just solved for x. All right, so that's one way we can use that theorem. Let's go to the next one. All right, don't look at that. You probably paused it. Okay. All right, well, anyway, try and do this one. All right, hopefully you tried that. Similar, we have an exterior angle. We have expressions in two interior non-adjacent angles. So we can set it up and say 6x, which is our exterior angle, is equal to the sum of the two non-adjacent interiors. So we have x plus 40 plus 3x plus 10. By the way, if you see any mistakes, feel free to say something to me, because it's at the end of the day, a little bit tired, and just running through things here. So if you see a mistake, say something. You might be right, you might be wrong, but let me know if you think you see a mistake. Alright, so now we can solve this. So I'm going to put this line down, the equal sign, and we have stuff to combine on this side. We can actually combine, this. And I'm going to erase this, put this in green, so we don't have all these different colors. Alright, so we have x and we have 3x on the same side of the equal sign, so we just add them up, and then we also have a 40 and a 10, which are like terms. So we are going to end up with 6x equals, now the x, which is 1x, plus 3x gives us 4x, and then 40 and 10 gives us 50. Alright, so we have 6x equals 4x plus 50, so I'm going to subtract 4x, subtract 4x. Notice that these are now on opposite sides of the equal sign, so you're not just going to add them. If you take something to the opposite side of the equal sign, or the other side, you have to do the opposite of what it is. So if it's already positive, which 4x is, you have to do minus 4x, and do that on both sides. We have 2x is equal to 50. Now we just divide by 2, and we get x is equal to 25. Alright, so there's another one. Okay, here's number 11 from the homework. It's the same concept. My arrow there. This exterior angle is equal to the sum of the two non-adjacent interior angles. So we can write 18x plus 5 is equal to 46 plus, let's see, I'm going to do minus 1, since that's a minus 1, I'm going to say minus 1 plus 8x. Alright? I know it says sum, but when you add a negative, it's the same thing as subtracting. So now we're going to see, can we combine anything? Well, on this side, left-hand side, nothing to combine. But on the right-hand side, we have a 46 and we have a 1, so we can combine those. We're going to end up with 18x plus 5 equals 45 plus 8x. All right, now we have to go across the equal sign. So now, a number of ways you could do this. So this is how I'm going to do it. Subtract 5, so we have 18x is equal to 40 plus 8x. And then we're going to subtract 8x from both sides. Subtract 8x. We end up with 10x equals 40. And then the last thing is to divide by 10, and you have x is equal to 4. So that's number 11 on the homework. Okay, this is number 15 from the homework. This is a little bit different because it said that you need to find the measure of angle S. So actually, if you look on the homework, it says find the measure of angle S. Angle. So you need to find X and then do more after that. So hopefully you got to the point where you see that this exterior angle is not inside the triangle, but it's equal to the sum of the two non-adjacent interior angles. So we're going to have 140 is equal to 8x plus 4 plus 3x plus 4. Alright, now I want to combine like terms. So I have like term, and then I have like term, and like term. So I have 140 is equal to 11x plus 8. Alright, now I'm going to subtract 8 on both sides. I'm going to have 132 equals 11x. Then I'm going to divide by 11. I'm going to have 12 is equal to x, and that's my x. But they didn't ask for x, they asked for the measure of angle S. Which one is angle S? Well, that's this one. So I know what 12, I know what x is, so I take that, plug it in here, so I have 3 times 12 plus 4, so that's going to be 36 plus 4, 40 degrees. So the measure of angle S equals 40 degrees. All right, there you go. Okay, I know this question you're seeing on the screen right now is not related to what we were just doing, but I forgot to do this one. I thought that this is a good one to do for you to see. So take a look at this problem. It's a little different, but it's related to what we were doing before with the side lengths of a triangle. All right, so take a look at that, see what you think about it. Try it out. Okay, looking at this, I know in this case the lengths are not represented by numbers but variables. So in this case, and I had students ask me this, you have 1y, so that y when you see it by itself means 1y. So that means whatever this side is, this 2y is just twice as long. That's what that means. So we have to think about it in those terms. So I want you to think about this. Is it possible that that third side could have a length of y? Well, think to yourself, remember, go back to the theorem. The two shorter sides have to add up to more than the third side. They have to be greater than. So in this case, these are two shorter sides, y and y. And y plus y is 2y. So is that greater than the third side, which is 2y? No. So y cannot be a length of a side, of the third side. But what about anything greater than y? What about 1.5y? Well, y plus 1.5y would be 2.5y, which is greater than 2y. So that would work. So anything greater than y will work. And remember, if you look here, s is the side length. So s has to be greater than y, but it can't be too much. So now consider this. So this is my first part. Now consider this. What if the third side was 3y? Could that make a triangle? Well, now my two shorter sides would be y and 2y. So do y plus 2y, is that greater than the sum of that? The sum of y and 2y greater than 3y? Well, y plus 2y is just 3y. Is that greater than 3y? No. So the side has to be greater than y, but it also has to be less than 3y. So now as I look here, how can I write that the same way we did before? We write y 3y. Remember, s is the side length. So our side length has to be greater than y, but less than 3y. Okay, here we talked about what it means for two shapes to be congruent to one another. If you don't have this definition, you need to write this down, be familiar with this. All right, exactly equal in size and shape, the corresponding segments and angles are congruent to one another. If two figures are congruent, they can be placed right on top of one another. It's very important to understand. If they are congruent, I can put one shape on top of another and they'll match exactly. We've been doing that in class where I've had students draw a triangle, and if they had it right, I'd go and put my triangle on top just to see if they were, if they had done it correctly. All right, we're moving into proofs now. That's what we've been working on, and these are the 5 ways that we can prove two triangles to be congruent to one another. I'm going to put up another video that's going to explain this. We've done some activities, but I really can't explain them on this video. We did them in class, so I'm moving right to the definitions. We started with side, side, side. We've been doing that today. We started to move into the second one, but we haven't really gotten into it that much. You need to be familiar with these. Okay, this is our side, side, side. So you need to know this definition. Triangles are congruent if all three sides in one triangle are congruent to the corresponding sides in the other. So you need to know this definition. Okay, here's an extra credit problem for you guys to do who want some extra work. And take a look at this problem that I've put up on the smart board that you should be looking at right now. And try and do it. I need an explanation in writing. And this is going to be due on, let's see, Tuesday, October 20th. All right, there you go. So hopefully you try this and see what you can do. All right.